Okay, this video is about adding vectors, and the vectors this time will be in the component form. I have one example for this video. We begin with the vector u being 3 and -7, and the vector v being 2 and 10. And then the operation is notated or denoted by the vector u plus vector v. So we have 3 plus 2 is 5. -7 plus 10 is 3. And then be sure to enter the component, enter it in component form. Then the next part, we will do similar to what we've done with previous units, where we find the exact and approximate magnitudes. And if you know how to do that, of course, you can go ahead and stop the video, but if you don't remember or just need help, I'll go ahead and go through them. Okay, so to find the exact magnitude of the first vector, I'm going to type in 3 squared plus a -7 squared, which gives me 58. So over here, we put the square, oops, there we go. Put the square root of 58. Okay, now the next part is we need to actually calculate that square root. So I'm just going to use tools here on the calculator, take the square root of the answer, which was 58, which gives me this number here, and I'll type on this side 7.62. So that's 7.62. And I'm going to be really curious to see if, when we add these together, do we get a total magnitude below? We'll find out. Okay, so let's do the next one. We're going to do the square root of 2. Well, we can actually do this in the head, right? I mean, square root of 2 is 4. And the square root of 10 is 100, which gives us 104. And then while I'm here, let's go ahead and do the square root of 104, which gives us 10.12. No, 10.20. Okay. We'll do that over here. 10.20. And then remember, this was the square root of 104. Okay, now finally we'll do the last part, which will take the square root of 5, which is 25, and the square root of 3, which is 9. So 25 plus 9 is 34. Now we take the square root of 34. So we take the square root of 34, and we get 5.83. So we'll put that over here. So one thing that we noticed is that the vector, if we just go through and add the approximate magnitudes together, it doesn't equal necessarily the total on the vector and the magnitude. So we need to be careful with that. This makes sense because if we have this vector here is 3, -7, so if I drew a picture of it, we'll go right 3, down 7, which would be something like this. And then the next vector would be 2 and 10, so go up 2 and, oops, it's kind of crazy, 2 and 10, way up here. So the resultant vector is right here. Now we're going to see more of that when we start doing graphics, but you can see that this vector here, just on my sketch, is going to be shorter in this case. So just the assumption we may have had that they may have added up doesn't quite work here. So there we go. And happy math hunting.